Good afternoon, everyone, and thank you for joining us online. My name is Melissa Mora, and I'm part of the community engagement team for the New England Res Network Infrastructure Project. I'm really glad that you've been able to join us online for this webinar this evening. This session has been organised to walk through the bulk corridor design refinement report for the new study area that's between the Bayswater Power Station down near Muswellbrook and the Central South Energy Hub near Walcha. Now, before we begin, I'd just like to take a moment to say Yama, hello and welcome, and acknowledge the traditional custodians of the lands we're all joining from today. I'm joining you all from the lands of the Awabakal people in the Hunter region, and I pay my respects to elders past and present. I'd like to extend that respect to all Aboriginal and Torres Strait Islander people joining us and acknowledge the lands each of you are joining us from today. Now, as many of you know, we have just wrapped up 3 weeks of community information sessions where there were many conversations about the new study area. So what we heard really clearly from the community is that you wanted some more detail about the assessment work that led to identifying the new study area. As a result, EnergyCo made a commitment to publish the bulk corridor design refinement report. That document was published last Tuesday. Now, the document contains a bit of technical information, and we know that it can take a bit of time to digest this. So today's session is designed to explain the report, outline the key findings, and give you an opportunity to ask the project team some questions. So now we understand that today's session was arranged at relatively short notice, and some of you may have only heard about it in the last few days. However, we also know how important it is to provide this explainer as quickly as possible following the release of the report, and to give you an opportunity to ask some questions today and to, of course, ask follow-up questions afterwards as needed as well. Now, anybody who cannot stay for the whole session or for anyone who isn't able to attend for any reason, this webinar is being recorded and will be available on our website, and we'll ensure that we share a link to that with you all as soon as it's available. So now to introduce you to our speakers, tonight I'm pleased to be joined with a number of people from our EnergyCo team. So we have Doug Paris, our Executive Project Director, Julian Watson, our Project Director, Phil Jones, the Planning and Environment Lead, Joel Gruber, the Design Lead, and myself. So these gentlemen will each deliver part of the presentation tonight, and then will be available for the questions afterwards. So just a couple of notes on agenda and housekeeping. So tonight's session will have 2 components. Number 1, the presentation from our team covering why the new study area, the assessment process, and the key findings from the report. And number 2, the Q&A session, which will immediately follow the presentation. So a few important housekeeping items before we begin. So you will be able to submit questions during this session tonight. So there is a Q&A tab along the top of your Teams there that you'll be able to see on your screen, and that's where you will be able to submit your questions. We do encourage you to wait until the presentation is finished before you send in your questions, only because some of your queries may be answered as part of the slides. Please note that we will be responding to questions only, so please ensure you submit questions rather than comments. And just a reminder that offensive or inappropriate language will not be accepted. And finally and importantly, if you see a question that you were planning to ask, please upvote it rather than sending in a duplicate question. This will just help us understand what questions are most important to you as a group and helps us make the best use of our time together tonight. We are aiming to wrap up this session at 6:30 p.m. so everyone can return to their evening commitments. So without further ado, thank you again for being here. I will now hand over to Doug Paris, our Executive Project Director, to introduce the bulk corridor design refinement report and talk us through that. So over to you, Doug.
Okay, just test my audio. Are we good? Can you hear me, Mel?
I can hear you perfectly. Thanks, Doug.
Fantastic. Thank you. Thanks for the introduction. Thanks, everyone, for joining us at 5 p.m. In your time. We acknowledge and appreciate that. Likewise, we understand if you've got things to do. So yes, recording it and making the materials available, we'll absolutely do that. We can jump to the next slide, or the first slide, I suppose, Mel. So I guess we've been developing the New England Res for about 4 years, I suppose, here at Energy Co. That includes the hubs, being where we'd like the generation and the storage projects to connect, and it includes obviously the transmission lines themselves, which connect the hubs, connects the transgrid, or our network with the transgrid network, and also connects the new 500 kV kilovolt lines to the existing network down at Bayswater, or near Bayswater Power Station. So that design's evolved a few times since it was publicly released in the middle of 2023. Most recently, of course, we've announced a change to the corridor for the 500 kV lines, which essentially connect the res to Bayswater. So I guess this webinar is intended to provide a bit more context to that change, in addition to some of the other materials that are out there, and I guess provides, Mel said, the opportunity for a bit of Q&A afterwards. So Mel, we can jump to the next slide. I don't plan to read every slide to everyone, by the way. That doesn't seem like a good use of time. From our side, we've followed a fairly typical design development process. Designs tend to evolve as we get more information, and I suppose if we find out more, we need to process that, and we obviously need to refine or change the design as we get that information. As you can see on the table on the right, there's sort of various stages that we go through. There's sort of an early planning stage. It's reasonably desktop-ish. We engage with technical studies and landowner and community feedback to progress through sort of some strategic designs. And then as we progress to more detailed design development, being what we refer to as a reference design, that's just progressively getting more and more detail. That's sort of the stage that we're at now. As we roll forward, we'd be rolling, as you can see there, into a more detailed and refined corridor for the EIS, the environmental impact statement, and then ultimately our network operator, who is the entity that will ultimately design and build and operate the project. They will do sort of the final detailed design. So there's a bit of a journey in the design development process. I think the key point on this particular slide is that we progressively do more detailed work as we develop, and we obviously need to consider and respond, I suppose, to the information that we find, whatever that detailed work is telling us. And obviously, in this instance, for this project, that more detailed work has identified some material challenges that we've needed to take into account. Come to the next slide. Thanks, Mel. This slide is, I suppose, it's just a quick. There's a lot of terminology that we use. I guess this was just an opportunity for a quick explainer, I guess, on a few points before we start talking to some of the metrics. And it simplifies things, but I'm hoping it's useful just to give context, if nothing else, to what we're like. It's an oversimplification, but it's intended just to help explain some of the metrics and why they're important. So I guess we start with the towers. We're essentially assembling large towers. They're tall, they're 70 to 80 meters, and they need large cranes to assemble them and then put them into place. Those cranes need a flat pad, and the towers themselves need a firm foundation, and typically a flat foundation. If you can imagine a pad that's about 70 meters by 50 meters, that's close enough to 3/4, I suppose, of a football pitch, of sort of as a flat surface. That's the preferred, that's the desirable layout. If we can't get that, then we can split it up. If we split it up, that tends to make work just go a bit slower. It's just a little bit less efficient. When it then comes to excavating, if you picture that pad on the side of a hill, rather than on the top of a hill or a nice sort of flat area, we need to excavate, I guess, to flatten that out. So that's quite a lot of excavation. Excavation leads generally to surplus rock, and if that rock can't be reused on site, and there's fairly limited opportunities to use that on site, maybe on some of the access tracks, but that's probably about it, then that needs to be taken away by truck and disposed of somewhere. So that generates a lot of truck movements that we just need to think about. Access tracks are how we basically move people and plant and equipment up to those locations. And I guess a steep track, there's limits on what you can get up a steep track. And at some point you can't get the heavy equipment that we want up there. they may be a little bit unsafe potentially, depending on the grade. So I guess the goal for that is to try and limit the grade to something that's reasonable. We've typically using an 18% as a bit of a threshold. It's not sort of locked in. You can go higher, you can definitely go lower, but it's just a useful benchmark to compare. And I guess when you're talking about access tracks, as we try and flatten an access track, you tend to do more earthworks. You're trying to, again, it's not that, or it's somewhat similar to the pads. You're flattening a track, you've got to do more excavation. Also means you've got to do more clearing of vegetation. So those are just some factors that feed into that. I guess if a track is too steep and we can't get the heavy equipment that we want to the tower site, then we might need to look at using smaller equipment, and that's okay. It's just slower and may not be as efficient. If we can't get that sort of equipment up, we might need to contemplate using heavy lift helicopters to actually move some of the tower parts around and even the tower itself into location. That is typically expensive and noisy and pretty slow. So it can be done. It's not saying it's not technically feasible. It's just about minimizing that in the context of what we're trying to do. And then I guess the sort of the final point there is these issues tend to be exacerbated when we are in close proximity to the existing lines, operational lines. So, on one hand, co-location is good, but in the area of steep terrain, all those points I just talked about are just exacerbated. They're just, we're sort of getting the second and the third best spots to build our towers. You're sort of further down the hill, that means you've got more, or up the hill, depending on where the best location is, but your excavation's a bit more, the access is a bit trickier. Trying to get the heavy equipment sort of in and around operating lines has a certain challenge. Excavating, particularly if you need to do blasting of rock, we've got a fair bit of granite around. Blasting near operating lines is got its own sort of risk considerations, and equally using helicopters in and around the operating lines. Again, can be done, just brings in different risks, different safety elements for us to think about. So I guess, Mel, if we can just jump to the next slide. I guess the map on the left there, there's only one map, sorry. The map on this slide highlights those areas where we identified challenges in the previous corridor. And I mean, this is in our fact sheet, so I don't want to dwell on it too much, but just, I guess the points that we were contemplating and concentrating in this area, two elements, I suppose. One is those water sources for the aerial firefighting. So Chappie Dam and Lake Glenbourne were relevant as sort of areas, challenges to weigh up. The other is the orange area that you can see there. And those are these areas that we're talking about having constructability challenges. And that's where we've got areas of steep terrain that we're looking at how we actually build in those areas. And the main thing I think to note on that map is it's not confined to one small area. It's quite extensive, particularly obviously focused on that area between Bayswater and where we get to the res boundary effectively. So you can see there, it's south of Lake Glenbourne. It's a decent area to the north of Lake Glenbourne. It's an extended sort of area up to sort of Walcha, and it's an area from, I guess, just north of Chappie Dam, so sort of Woolooma up to Bendemeer. There's a lot of text on the right that I'm not going to read. It tends to be an extension of the previous slide, I suppose, as to taking those challenges and constraints that we're looking at, and this is a summary, I guess, and this is in the fact sheet, so I won't reread all that. It's I guess the conclusions about the challenges to the previous corridor. Jump to the next slide, thanks, Mel. So I guess these challenges led us to look at a few different things. Firstly, we looked at refining the design in the existing corridor, and I'll come back to that in a minute. We also looked at alternative corridors, and so we were looking at those that we looked at previously, and we were also having a think about a new corridor as well. This slide shows some of the previous routes that we've looked at. I wasn't planning to talk to all of these in detail right now, but you can see that we've got, I guess the main ones of note would be the Midwestern route and the TSR route. But we have looked at other routes along the way, and this does show the new study area as well in that sort of teal colour, I guess it is, the dashed line running through there. And I guess an observation on this, there's within the res, so sort of from the res boundary on the plateau, let's call it, from there up to sort of central south hub, we do have 3 routes that are fairly close to each other there, Midwest, the TSR and the new study corridor. South of that, though, they're quite different, I guess, as far as how we actually get from Bayswater up onto the plateau are quite different. That's quite a big differentiator, and that's, I guess, dealing with that challenging terrain that I was talking about on the previous slide. Jump to the next one, Mel. Thank you. So yeah, we did look at refinements to the existing corridor. Guess what we mean by that is just seeing whether we could actually make changes and address those areas, the aerial firefighting operations and the challenging terrain, the constructability challenges that we had generally within that corridor. And that looks at things like moving towers, maybe longer spans, using different foundation types, using different construction methods and equipment as well. So weighing those up as alternatives to see if those were providing opportunities to address those challenges and those constraints through that area. And I guess what we found through that is they tended to partially address the issues. And as you can see, because of the extent of where those challenges are, you could sort of address some areas. You could sort of sort out the southern part, but you hadn't really sorted the northern part unless you actually started looking at effectively, I guess, a new corridor. And that obviously had led us to have a look at moving to a new study area. That is clearly what we've announced and why we're holding this webinar as well. So for those options, we did look at them across a range of criteria. We call them our planning pillars. They align with the transmission planning guidelines, sort of environmental, technical, community, strategic and economic pillars. There is not a perfect answer to get a corridor through here. I think it's reasonable to say that every square centimetre of this area in New South Wales is important to someone. So these are not simple processes, I guess, to work through. And that's, I guess, what we're trying to present or have presented in the report is, our process of working through that, looking at different metrics and weighing those up side by side, so you can have a look at our assessment. You might form different conclusions, and that's fine. But we're just sharing how the processes that led to our decision, and ultimately that's obviously led us to select the new corridor as preferred over the previous corridor. I can jump to the next one. Thanks, Mel. Starting to read my mind. I like it. So we have published the report that is on our website. I think we published it just last week. So that's, like I said, that's to share the analysis and the metrics behind the decision that led to us changing the corridors. That was a rigorous process. We have had as well an independent review panel challenge that work and review the work as we'd done it, and I guess challenge and inform whether we'd actually thought about things the right way. Ultimately, they concluded the same as we did, but that is, like I said, that was an independent review panel that was used to work through, I guess, challenge and validate the work we'd done. So this report's provided for transparency. It's not strictly to, not to re-prosecute the decision, but we do want to make sure that people have got, there's obviously a lot of interest and appetite in understanding why we are where we are, why have we concluded what we've concluded. There are some redactions in it. I know people would prefer that they were not. We've tried to limit that. There is some information in there that's commercially sensitive, just related to where we are in our network operator procurement process. It's mostly around cost. We jump to the next slide, perhaps. That is, so cost, like I said, cost is one of those areas that we've redacted. You can see on the right, I guess, the broad conclusions. This is in the report. This is a very high level summary, but the broad conclusions that we've reached are that with the less challenging terrain, the improved access, the reduced volume of earthworks, and volume of earthworks also maps to time and the number of trucks and the surplus materials that we need to carry. less clearing of vegetation, and that relates to biodiversity offset costs, better access, which has a component of that relates to doing earthworks. It's got a component to do with productivity, and it's, I guess, to the extent that we can get more conventional tower construction, that is generally a good thing. And when I say conventional, that's using cranes. That's probably the most efficient way for us to build the towers, to the extent that we still have some limitations. And I should just be very clear, it's not like we've resolved every challenge in this corridor. It's just improved, materially improved, but there is still some very challenging terrain areas that we need to resolve. So these are metrics that typically are improved rather than totally resolved and solved. So less reliance on heavy lift helicopters is also a good thing. It's cheaper, it's generally safer, and it's got less noise associated with it. And as I sort of observed earlier, less work next to the 330 kV lines. And again, that comes down to productivity and safety and just general disruption for outages and the like. So key points to all that is we have assessed that this is a simpler and a faster and a safer route to construct the corridor, the transmission lines in. It's got less risk from our perspective, and if you add those factors up, that will lead to a lower cost. So I think with that, I'm going to pass to Phil.
Thanks.
Actually, I'm going to pass back to Mel. I'm not going to pass to Phil because we just need to do some quick audio things, but back to you, Mel.
Not a problem. Thank you so much, Doug. Really appreciate that overview. So now we're going to move into the environmental and land use considerations. So welcome to Phil Jones, our planning and environment lead. Over to you, Phil.
Thanks, Mel. Thanks, Doug. Good evening, everyone. I'm Phil Jones, EnergyCo's planning and environment lead for the New England project. I'm just going to take us through some of the environmental and land use considerations that we considered, and in particular, some more detail on the aviation constraints that we had around Chaffey Dam and Glenbourne Dam, and how we considered those in our assessment. So in broad terms, how we consider bushfire risk for the project, we engage with emergency services, in particular rural fire services, as well as other emergency service operators during all stages of the project. During the initial planning stage that we're in now, we'll continue to work with all the key stakeholders through the construction and operation phases of the project. In broad terms, we consider a range of factors in our bushfire assessments. We consider things like the history of bushfires in an area, mapped bushfire-prone land in the landscape, the density and the type of vegetation in the landscape, topography, access, and a range of other factors that affect the bushfire risk when we're planning the route. Our engagement with RFS and other bushfire-related stakeholders to date has played an important role in where we're at, and we've taken that feedback from RFS and other stakeholders as we've planned the route. For the EIS, we will be preparing a very comprehensive bushfire assessment, which will consider a range of factors, as well as consultation with the local community and local brigades as we plan the route. When we move to a construction phase, we will then be required to prepare detailed emergency plans, and as part of that, we'll have a very detailed bushfire management plan, which will go into even further detail on how we'll manage bushfire on a locality by locality basis. Do you want to pass on to the next slide, Mel? So we heard recently that that the community was keen to get more information on our engagement with RFS and other stakeholders in relation to those key constraints that we identified around Chaffey Dam and Glenbourne Dam. So this slide just goes into some of the engagement that we had with stakeholders as we plan the route. So from late last year, essentially, it was identified through our engagement with the community and also with RFS and other stakeholders that there were potential constraints around both of the dams. So in earnest, at the end of the last year, we commenced detailed consultations with RFS's State Operations Branch, as well as their Northwestern Area Command. And what we wanted to really understand was how both of the reservoirs are used for aviation related bushfire fighting. What we heard was that, yes, RFS used the dams for rotary wing aircraft, but importantly, there's a couple of local operators, Pays Air Services and Kennedy Air, that use both Chaffey Dam and Lake Glenbourne for fixed wing bushfire fighting purposes. So we've been working with Pays and Kennedy Air since this time, as well as with RFS and other stakeholders in emergency services, including CASA, Forestry Corp and National Parks, to understand how the dams are used for firefighting and in particular, how they're used for the fixed wing firefighting operations. In broad terms, what we found was that both dams are important. They are both used, particularly by the fixed wing Fireboss aircraft. And as well as that, Lake Glenbourne is used as a training facility for Fireboss aircraft operators. So I guess what we wanted to do around both dams was to identify the constraint was we wanted to identify exclusion areas that we could map and we could ensure that the transmission line could be planned around those areas. I guess EnergyCo's objective is to not compromise bushfire fighting services for the regions. And what we found was, as I said, both dams are important for bushfire fighting resources in the area. So this slide just shows some of those exclusion areas that we developed around both of the dams. Lake Glenbourne is shown on the slide or the picture on the left. The previous study corridor is shown as that orange dotted line. What we found was that where that light blue area is one of the key areas for the Fireboss aircraft on Lake Glenbourne. It's not shown on that figure, but there's also the north-south area of Lake Glenbourne, which is also used in some weather conditions. And in more westerly winds and easterly winds, this eastern portion of Lake Glenbourne is used. What we found was that where the previous study corridor is an area that the Fireboss used to come in, used to as they're coming into land, but also in the takeoff. And the picture on the right is Chaffey Dam. So we did a similar exercise there. Again, the previous transmission corridor is shown in orange there, and the exclusion area that we developed essentially showed that the transmission line was a constraint to takeoff operations at the dam. I'm going to move to the next slide, Mel. So we used a range of inputs into our aviation assessment, which we developed with inputs from Pays and Kennedy Air, as well as Water New South Wales on dam water levels and RFS as well. So some of the inputs were the flight performance information, which we got from detailed flight paths obtained from the operators. Some of the the flight data from the original equipment manufacturers in the operating manuals for the Fireboss aircraft, as well as as I said, the Water New South Wales information regarding dam water levels. We were able to get flight track data from actual bushfire fighting events from Chaffey Dam from December of last year, and some data from Lake Glenbourne that was provided from 2023. So we were able to use real world data in developing these exclusion zones. And then some of the assumptions are there, listed there on the right. I won't go into that in detail, but essentially what we tried to do was take a very conservative approach to our assessment, because we didn't want to compromise firefighting operations at the dams in all prevailing weather conditions. So moving on to some of the other broader environmental and land use criteria that we considered through our assessment in the bulk corridor design assessment report. As Doug said, we assessed the route using multi-criteria analysis, using a range of criteria against our key planning pillars. Some of those things from an environmental point of view included agricultural land, important agricultural land, including mapped BSAL or biophysical strategic agricultural land, as well as the critical industry clusters, which are mapped in the New South Wales Government's strategic regional land use plans. In terms of BSAL, the revised study corridor does pass through substantially less BSAL than the previous corridor, around 140 kilometres less. There is more equine CIC on the new corridor, which is concentrated in those areas to the south. In terms of agriculture in general, the new study corridor does pass through about 900 hectares less agricultural land, and also about 80 hectares less cropping land in total. There is more forestry. We now pass through Nundle State Forest, and we're working with Forestry Corp to start our assessments on the state forest land. In terms of bushfire prone land, there's about 1,000 kilometres less, hectares less of the highest category bushfire prone land. That said, we will now move to doing further assessment on bushfire as well as other matters in consultation with RFS and stakeholders. We've heard the impacts to koalas is, of course, an important aspect for the community, as well as broader environmental impacts. We did consider koala habitat in our assessment of the two options. The revised study corridor we found has passed through about 500 hectares less koala habitat than the previous study corridor. There are some mapped koala clusters and arcs or areas of regional koala significance on both the previous study corridor and the new study corridor. The areas of arcs on the new study corridor mainly related to around up in the north, around Armidale, and then around Nundle State Forest. But I guess where we're moving to now is to start our on-the-ground biodiversity surveys to further investigate koala as well as other flora and fauna and biodiversity matters on the route.
Great. Thank you so much, Phil. That was great. I am now going to introduce you all to Joel Gruber. So Joel is our design lead for the project, and he's going to take us through the constructability assessment and what the team has been looking at in the new study area. Over to you, Joel.
Thanks, Mel. Just testing my microphone, just making sure that I'm clear, everyone can hear. That's great.
Loud and clear.
Thanks, Mel. So as Mel mentioned, I'm Joel Gruber. I'm the design technical lead for the New England Res project. On this slide, we've got a bit of an overview of some of the key statistics here, which we'll go into a little bit more detail on upcoming slides. Just want to take a moment here to talk about the process. Doug mentioned early on that in terms of the typical design process, when you're starting through looking at arrangements for these large-scale infrastructure projects, you take an early stage, you look at projects in terms of a strategic design development lens. And so you're using sort of high-level comparison tools for options assessments. You're basing it on line lengths and components through there. What this statistics are coming from is that next level of detail that we did, where we were coming away from those high-level strategic design developments, looking at specific arrangements in terms of the transmission line alignment, looking at tower pad configuration, doing civil earthworks modeling, doing access track modeling to get some comparisons through there. So in terms of key statistics, you can see that the new study area performs better, and in some places considerably better than the refined preliminary study corridor. And that's on the basis of going through and doing specific modeling and looking at arrangements for the transmission line on both of those alignments and trying to get a comparative across that. So that's looking at actual earthworks modeling. So that's why we've got quite specific numbers in there. We're using it on a baseline. So as opposed to using high-level metrics and the like through there. So these are comparisons of specific arrangements, civil designs that have been conducted. Maybe just go to the next slide. Thanks, Mel. So going through some of these items in detail. So the first one there is noting about aggregate elevation. So when we're designing transmission lines, they need a particular arrangement to have efficiency of design and to find viable alignments. So transmission lines are typically the most economical when they're between 400 or 600 meters span. So that's where towers are located in that sort of area. And then the transmission line conductor is able to sag between those two transmission towers. So when we've got very undulating terrain or terrain that goes up and down considerably, it's hard to find locations to site those transmission line towers. So what ends up happening is you end up having to locate transmission line towers on the side of hills, on the side of mountains. You end up having clashes with the conductor as it sags between transmission lines. So you end up having to have more transmission line towers and arrangements through there. So you can see on the new study corridor, there's a significantly less amount of aggregate elevation. And what we're saying there is we're just adding up the cumulative ups and downs along the alignment. So that essentially shows that there's a better transmission line route and able to site transmission line towers so that you can have more efficient tower design, so that the conductors can actually span between the towers without, while meeting minimum ground requirements. And also, I guess it sort of lends into some of the arrangements coming up about civil earthworks and tower pads. So next slide, thanks, Melissa. So in terms of access tracks, this sort of ties into the amount of towers that you need. On the previous study corridor, there was some sections which were co-located with the transgrid line. So when we were looking at the previous study corridor and seeing what access tracks we needed, we were looking around through there, looking if we could utilize some of those existing access tracks. What we were finding is that some of them may be suitable, but a majority, quite a large number of them wouldn't have suited the purposes, or that the alignment in terms of where you put those access tracks wasn't being able to be used. So the existing transgrid line has located itself, say, taking the best route through the undulating terrain, which means that we had to sit adjacent to it. In some of those cases, it meant that we were on the side of mountains, side of very steep terrain, which meant that new access track would need to be built to be able to access through there. So there was a significant drop in terms of the amount of access track, even considering utilization of the existing access tracks or goat tracks on the existing transgrid network. So There was also consideration there for some of the grades. So as David mentioned at the beginning, less than 14% is generally suitable for conventional construction methodologies. As you come further and further up, you can get up to slopes exceeding 18%, would typically require some method of non-conventional construction methodology. Doesn't mean that you can't do it. However, it slows down productivity, slows down arrangements, and also I guess there's a quantum there about how often you have to do it or for how many lengths you have to do it in terms of maintaining a viable and prudent transmission line alignment. So also we're noting that we're saying grades over 18 to 21%, grades over 18%. In some of the locations under the previous study corridor, we had quite a large amount of transmission line, access tracks which had grades over 21%, which is then starting to head towards the use of potentially heavy lift helicopters and the like through there. So overall, the new study corridor had a more prudent transmission line alignment with the undulating terrain, which meant that the access tracks was lesser in terms of what we needed to go there, even considering some use of the existing access tracks along the existing transgrid line. Thanks, Mel. Next slide. This one through here, I guess, is just indicating when we've got tower pads, so when we've got a transmission line tower, we need to have a tower pad. And initially, the easiest way to do it is just make a large flat area. In locations where it's undulating terrain, you may be better off in terms of having a stepped tower pad. So that means that you have a tiered approach for some of those tower pads through there. So a tiered approach means that you can reduce down some of the civil earthworks. So I guess this one in conjunction with the next slide, which talks about overall earthworks quantities, you can see that the pad type C, we ended up using more of them in the previous study corridor. So we're trying to really work the design hard. We're trying to utilize a more complex pad so that we can reduce down the earthworks, but it still results in a quite a large earthwork delta between those two. So effort was conducted in here to try and find ways to minimize earthworks, try to minimize what was happening through here with the tower pads, resulting in essentially there's a movement from pad type C and pad type B into pad type A, which is essentially meaning that there's a simpler construction methodology and more viable transmission line direct. Next slide, thanks, Ms. Okay, all of those items together all work into earthworks, the amount of earthworks that you need to be able to build the line, which comes to where you locate towers, the slope and steepness of where you're locating those towers in terms of what you have to excavate out to be able to have a location where the transmission towers can be built and be located, as well as access tracks to locate those towers. So from that, you can see a considerable difference here in terms of the new study corridor versus the previous study corridor. When you come to big numbers like this, it's sometimes hard to get a magnitude of how big that is. So, 1.5 million cubic meters. If you take a football field, 120 by 70 meters, essentially that's 180 meters high of fill there. So you've got a football field with 180 meters high worth of fill on top of that. Indicatively is the sort of number that we're saving there. So it was a considerable amount of earthworks that you're saving in terms of alignment arrangements associated with tower pad modeling and access track arrangements. Thanks, Melissa. So a reduction of earthworks means that there's a reduction of construction vehicles that need to move that earthworks, time, duration on local roads and the like through there. So I guess this is directly equatable to that amount of earthworks that was saved. We're reducing spoil truck movements, which reduces the impacts on local roads, those movements going between locations to be able to move around. Also has benefits for construction, constructability timeframes, and the like through there. Thanks. Next slide. Just a brief one on the non-conventional construction methods. So in terms of use of heavy lift helicopters in steep or remote areas, this was something that we were looking at, and it was heading towards because of the amount of difficult to reach transmission line towers, as well as the access tracks, the complexity about the grades from the access tracks was meaning that we were heading more towards of a heavier reliance on heavy lift helicopters. So for those heavy lift helicopters, there's some, you can use them to build transmission line towers. There are a few limitations in there in terms of and impacts. You do need some significant parcels of land to support the helicopter construction in terms of logistics, assembly, being able to efficiently, safely, prudently be able to use those heavy lift helicopters to be able to build. The flight paths for helicopters would have to be something that we would be assessing in terms of EIS and use of those helicopters, timeframes, construction noise, impacts to landholders in terms of helicopter usage. In assessment for constructability, there was a view that the helicopters operation likely be limited by several different things, including fauna breeding seasons, limitations to operations, equine facilities, and the like through there. So probably lastly on that one is that that the combination of having undulating terrain, difficult terrain, alongside the existing transgrid lines would mean that you would end up having to have potentially helicopter construction adjacent to a live transmission line, which has a number of safety implications. It's a high risk activity. The quantum of locations where this may be required was something that was a significant risk, and it's another benefit of the new alignment. The updated study corridor is that we've dropped away that dependency. Next slide, thanks. This slide's fairly similar to what just talked through there about safety and program risks. Essentially having difficult construction, undulating terrain, lots of construction movements builds up risks in terms of construction, in terms of safety, as well as construction risks in terms of what you can do in the timeframes that you need. So previously I had about 64 kilometres of the 500 kV line constructed adjacent to the 330 kV lines in steep terrain. So there was significant risk in there in terms of how that would be conducted. Not a case of you can just do that when you want to as well. There's several implications in terms of getting approvals, allowing for that to happen from a safety program risk, allowing for the helicopters usage, programming, logistics-wise, and the like through there. So the new corridor, significantly superior in terms of that safety and design and safety and construction, where it minimises those chances of incidents associated with heavy plant on steep access tracks in a number of locations. We do have still some areas which are challenging terrain, but a significant amount less. Significantly less non-conventional construction, and the tower construction adjacent to the live 330, particularly in undulating terrain, has been significantly reduced. So we've just got 4 kilometres in the corridor north of Bendemeer, and that's in flatter terrain. So very unlikely to need helicopter usage through there for the construction of those transmission line towers. Next slide, thanks. And another little bit of input just on that co-location with existing transmission lines, which I think I've covered in the previous one, but essentially it's the safety risk of having to have non-conventional construction methodologies next to an existing transgrid line, and particularly on the side of hills, just because that existing transgrid line has picked out some of the best location to be able to traverse the undulating terrain, which means that we get pushed onto more on the slope of the side of the mountain, side of the hills, and the impacts in terms of that. Thanks, Melissa. I think that's the end of the slide deck for that item.
Beautiful. Thank you so much, Joel. And now we're going to move to our last speaker. So welcome to Julian Watson, our Deputy Project Director. Julian's going to bring everything together and now talk through what this means for the next steps in the project. Over to you, Julian.
Thanks, Mel. Just making sure everyone can hear me okay. Great. So look, thanks to Doug and Phil and Joel for walking us through those sections. In a sort of summary sense, we've undertaken a really significant body of work, across 2025 to compare those corridors and over a whole range of metrics. And based on this analysis, the new study area does provide us with a better overall set of outcomes. I think we've mentioned probably a couple of times tonight, though, that there are still some areas of really challenging terrain that we need to navigate. That's pretty unavoidable, getting from where we need to get to in the New England down to Muswellbrook to join onto the network. Key to that really has been reducing some of those constructability constraints, and that's enabled us to get better value for consumers and ultimately pay for the project through their energy bills. Probably really important for us to note, though, that along with that challenging terrain, of course, there's any option we take through any of this, as Doug mentioned, every area is spoken to, and there's still landowners and communities across the project that we need to continue to work with and liaise with. Just move through to the next one. And on that, we've community feedback is really critical to informing the development of the project. Many of you will know we have an open have your say period at the moment, so we've extended that for 2 weeks, so it closes on Friday the 12th of December. We're really keen to have a conversation with landowners or communities on how you use your land, hear your views. We want to be able to consider all that feedback as we refine our 3-kilometre corridor down to a 1-kilometre wide corridor early in 2026. From our perspective, we've started some of those conversations with some landowners and with some communities. We're already there working away to see what we can work out based on the really good feedback that we've got from people to date, and hope to continue that with more folks as we move forward. After the consultation period itself, we'll develop a report outlining the key topics that community have raised and Energy Co's broad responses to that, when we'll share that report once it's finalised. And of course, we also continue to welcome community feedback on an ongoing basis as we develop the project and move through our process. Just about the scoping report. So we've received a fair bit of commentary on the scoping report. Important to note, it'll be a standalone document, doesn't assess the project in detail. It's the aim of, I guess, the scoping report is to describe the project in simple terms and include an analysis of feasible alternatives that we've considered, provide an early indication of some community views. And one of the really key things is that it identifies areas or key matters that, in particular, planning and other agencies will require us to undertake further assessment on in the EIS, and agencies will use that to outline the approach that Energy Co will use, or they will comment on our proposed approach, so that we have got proper regard to any relevant government legislation, to any of their plans or policies or guidelines. So a really important part of the process, and we're aiming to have that out later in this year. And we're currently, I guess, continuing to develop the EIS itself. We've undertaken many thousands of hectares worth of investigations for biodiversity, for heritage, Aboriginal heritage, a whole range of geotechnical investigations, etc. A whole lot of that remains current, even with the change, and we've already begun some of those assessment on different bits of land in the new corridor as well. Might just move through to the next one, Mel. So next steps for the project. Right now, undertaking and continuing our biodiversity, heritage and visual field investigations within the new study area where we've been granted access. as I mentioned, in late 2025, looking to provide that revised scoping report to DeFi, to Department of Housing and Infrastructure, Planning, Housing and Infrastructure, which will reflect the new study area and any of the changes we've made, some of those based on community feedback. Early in 2026, we'll look to put out our revised 1 kilometre corridor between Muswellbrook and Walcha. So again, bringing that 3 kilometres down to 1 kilometre. Based on any of the landowner consultation and additional technical studies that we're able to undertake. And then in the second half of 2026, we'll be putting out the environmental impact statement itself. So lodging that with Department of Planning, Housing and Infrastructure for assessment, and of course, really importantly for public exhibition.
Great. Thank you so much, Julian. And thank you to all of our presenters as well. So now we're going to move into our questions and answers part of the session this evening. So you will be able to submit your questions and you can start doing that now. So there is a Q&A tab at the top of your screen. There's a question mark and a speech bubble. If you click on that, you will be able to enter your questions into that space there. So while you're doing that and having a look, I'll just give a quick reminder on how we're going to manage the questions for this evening. So we do ask you to keep your questions concise and focused. Comments won't be addressed as part of this forum. If you do see a question that you'd also like answered, you can upvote it, which helps you move the most requested questions to the top of the list. So you can upvote by clicking on the small arrow button underneath the question in the Q&A section once they start appearing. Where we receive multiple questions that are very similar, we will answer one that captures the key theme so that we can get through as many topics as possible tonight. If we run out of time or we don't get to your question, just a reminder that you can always contact the project team directly at any time, either through the project number or email, and we're going to pop those details into this session as well so that you've got that on hand. And we'll also ensure that this recording will send you the link so that you can come back and watch that anytime as well. So with that, let's get started. Our first question, so does proposed stage 3 in bulk corridor report require a third transmission line? Who we might throw that to?
I can respond to that.
Great, thanks, Joel.
Yep, so stage 1 is the 2.4 gigawatts transfer capacity, stage 2 is for 6, and then potential stage 3 is for 8. The two 500 kV lines are good for 8 gigawatts transfer capacity. So we don't expect that there would be there's not need to include another line to be able to reach that. There may be some works that are required because of the configuration for power system modelling, but that would be in terms of some equipment at potentially energy hubs, potentially outside of the network. It does depend on the makeup of generation. So not a simple question to answer about what is required for 8 gigawatts, but the two 500 kV lines that run from Bayswater up to the res are suitable for 8 gigawatts. So they're not needing a third one for stage 3.
Brilliant. Thank you, Joel. All right, we've got a question from Bruce Foy. So what statute is used for compensation? Julian, is this one you might be able to take?
Yeah, I can talk to that in the general sense, Mel. So compensation for this project is kind of under two banners. The Just Terms Compensation Act is the primary way we look to assess and compensate landowners for the impacts to their property, and that's on a very individual basis, depending on, I guess, the way they use their property, the potential impacts that the project has. It's really a very detailed set of conversations and discussions and assessments by professional valuers. That's separate to I guess, also a per kilometre basis rate that is paid at $200,000 a kilometre over a 20-year period. That's not included in the Just Terms compensation side of things, but is a separate set of payments.
Thank you, Julian. All right, we've got a few questions that have come through from Tabitha, so we might just go through them one by one. Joel, I think the first one's probably a good one for you. So where is the line going after the North Hub? Is this a strategy to connect New South Wales to buy coal power from Queensland?
Yep, so the transmission line for stage 1 and stage 2 under this project runs to a North Hub near Warrane and up near Gyra. So there is provision there for a connection into the existing transgrid network there, which runs up near Gyra. There's the existing line, apologies, I'll use some technical terms there, but there's an existing line 8C, 8E, which run up there. So the view is to connect into that existing line so that we can capitalise on generation in the existing network to the north. In terms of arrangements for future stages and related to Queensland connections and the like through there, there are some discussions under the ISP, which is the document that comes out from AMO, which talks about long-term outlook for power generation. It talks to that connector between Queensland and New South Wales. There's some provision there that we are allowing that could come through there. However, the development of that project is quite low and a long way away. It's in terms of more feasibility components. So the intention for stage 1, stage 2, what we've got in this project is just to build up to north. With the idea is that we don't preclude that something could occur in the future, and that's subject to a number of things about continuing versions of the ISP coming out and seeing what New South Wales consumers need.
Thank you, Joel. The next one I think is talking to the viability of generators. Doug, I might throw this one to you. So why build a transmission line to a res that's failing?
Sorry, we're just making sure. Okay, here we go. Audio switch. Well, I guess we're building a transmission line to the res. The res has been declared. Developers are developing projects throughout the res. We're talking to a number of those developers. None of them are committed at this point, but I think we've probably previously talked to that. But I guess that is a process that they work through as far as they develop their projects. We would look to run an access right tender or tenders potentially in the future. The timing hasn't quite been resolved in that, but that is essentially to determine which projects will connect to the res and allocate them the rights to connect to our project, to our new transmission lines. So that is in the future. There's a lot of projects that are there's a lot of developers out there. Not every project is going to qualify. Not every project is going to connect. And we don't know exactly which ones are going to connect at this point. So I guess I wouldn't say that the res is failing. I think there's a lot of generators that are developing their projects and the capacity that they're developing is sufficient to meet the needs that we have at this point in time. As I said, I can't point to the exact projects that are going to connect because you haven't run that process yet. So that will continue to evolve. That's one of the challenges that we've got, is running that in parallel as we go. Mel?
Thank you, Doug. I'm going to have another question from Tabitha, and then we've had some more pop in. So I'll go to the others, and then we can always come back to go through Tabitha's other questions if we do have the time. Joel, this is probably one for you just about snow ratings as well. So at the Walcha Energy Co meeting, it was said we have Nyangla and Walcha as unaffected by snow. Has this been rectified now or even considered as a problem with construction and pricing?
Yeah, so snow loading is dictated under Australian standards in terms of the requirements for when you do include it. Typically, it's based on elevation and proximity arrangements through there. We have assessed that under the reference design, so it's something that we are looking at. I guess in terms of the arrangement for the new study corridor, there are isolated cases where the transmission lines are at a higher elevation than they were on the previous alignment through there. However, they're typically isolated locations. There'll be some locations where snow loading may need or will need to be considered. In conjunction with that, we also have typically on these large the RES projects and transmission line projects, we have a higher wind loading requirement. So we already have a bit of a more stringent component there about wind loading anyway. And then when you account for snow loading, there's some balance off points, because you end up having, you don't take the worst event of the worst event and the worst event. You take a measured approach under Australian standards. So to answer the question, snow loading has been considered in a reference design arrangement that we're looking through. Ultimately, there'll be a design that is done by the network operator, and we're dictating that they will include that as well. They'll have to abide by Australian standards and the weather configurations that they have in the area, so they have a prudent and efficient design.
Thank you, Joel. All right, we've got a question regarding the Just Terms Act from Tim White. Thank you, Tim. The question is, it is agreed that it is not currently fit for purpose and is out of date. It is currently under government review. Once the review is completed, will landholders receive increased payments if the new act allows for it? Julian, is that one that I can throw to you?
Yeah, no problems, Mel. I mean, obviously, if the Act is updated or if government policy changes, we'll abide by that. That's guiding principle for us, so we'll continue to do that.
Thank you, Julian. All right, we've got a question from Jackie Osmond. The question is, can developers connect to the transmission lines that are outside the RES and along the transmission line route? Doug, can I throw that one to you?
You can. Thank you, Mel. So I mean, it's good. It's a good question. I guess the purpose, if we just go back a little bit, the purpose of the RES is to encourage and activate the developers to develop their projects inside the RES. We're building the transmission lines to the RES. Our reference design has 5 hubs. Those hubs are where we want the generator projects to connect to. That is the purpose of those hubs, or it's one of the purposes of those hubs. So that is that's the intent. That's the purpose of the RES, is to actually have those projects develop in an area where the resource is strong, and we provided transmission and the right infrastructure to actually connect those projects from the RES to the existing network, and ultimately, obviously, onto electricity consumers. To answer the question, our strong preference is no, that they don't. We're not setting up the project for projects to be able to connect to the transmission lines outside of the RES. It's very expensive to do that, and it's not actually in line with what we actually want developers to do for the RES. So we're not talking to any projects that are in that instance. I guess for clarity, there's 1 or 2 projects who are right on the south end of the RES who have approached us and asked if they can connect to the transmission line route just outside the boundary of the RES. Question if that's actually economic, and question if that's actually what we want developers to do, to be honest. So that is something that we are working through with those generators, and keeping in mind the principles, the founding sort of principles of what we actually want the RES. So certainly, I guess if the question is aimed at would we expect to see projects popping up, in the valley as we're coming up, that's not our intention, no.
Thank you, Doug. All right, I'm going to go back to some of Tabitha's questions while we wait for some others to come into the Q&A. Joel, this is probably one for you. How can you have accurate figures for access tracks on the new study corridor when it hasn't been refined yet?
Yeah, so we do take a example arrangement through there, and then we are measuring the deltas versus what we are discussing with specific landholders and specific arrangements through there. So we do have a version, and I guess the study corridor is then to find out the constraints so that we can test and arrangements, so that we can find a viable alternate through there. So that, those quantities that are in there are some reference, but in terms of overall, we did also look at adjacent transmission line alignments as we were going through. So we expect that there's not a significant gap between, say, moving the transmission line alignment a little bit to either side compared to that reference alignment that we've got through there. So we do have a basis doc that we come through, and it's based on information we've got to date, and we're comparing that as we go through. But as to date, we haven't seen anything in terms of going out through the study corridor that has significantly impacted those arrangements.
Thank you, Joel. I've got another one for you. So one of the questions is, the plateau is one of the wettest and most unstable soil sources in the state. Talks about that some of the equipment may sink. Has this been part of the assessment, or have we only assessed the grade of the hills?
No, and yep, so we do geotechnical investigations along the alignment as well, where we're able to, sometimes to find various stratum, to find various conditions as you move through and around. The wetness of the ground is something that we do consider in terms of the constructability regimes through there. Typically, we will build up a pad, build up some arrangements through there so that there is a bit more of a resistant to weather arrangement for the constructability, rather than, and I guess people in the region will probably see about getting bogged and arrangements through there. So the transmission line tower arrangement also accounts for that, because the transmission towers are just at bespoke locations as you move through and along. So you're actually only needing to get to certain locations, and we do try to locate them in areas where constructability and take consideration of the ground conditions through there. Where there are wet soils and wet configurations, there are ways to alleviate that through construction via building up of temporary pads that can then be removed following. There's also constructability methods so that we can construct in wet areas and areas that don't have great stability around through there. So there's a two-pronged approach there, is that we do assess ground conditions, and where there are conditions that are going to be wet, there's bespoke construction methodologies that can be used to alleviate that.
Thank you, Joel. All right, Phil, I've got one for you. This question has come in through from Mark. What compensation are you offering for farmers who lose their EU market for cattle due to the EU deforestation regulation, which benchmarks trees as at 2020?
Thanks, Mel. Yeah, our understanding is that this relates to deforestation undertaken by, say, a farmer for their purposes, whereas Energy Co would be undertaking clearing for a project. So we understand at the present date that it would not affect a farmer's ability to sell in their cattle into the EU.
Thank you, Phil. I have another one with you, so I'll stick with you for a moment. So this question's come through from Kate Whitehead. Thank you, Kate. The question is compensation for access for biodiversity, heritage and field investigations potentially a third means of compensation for impacted landholders, in addition to the two other forms of compensation, which would be the just terms and the strategic benefit payment?
Yeah, I guess if I'm hearing that question correctly, so Energy Co will have residual biodiversity impacts that we will need to offset, in accordance with the offsetting rules. Biodiversity.
That's the question. I think it's will people get could a landowner be paid for us to access their land to undertake investigations? I think is probably the nub of the question. I think.
Okay. Sorry if that's the nub of the question. We are seeking access for our surveys on a voluntary basis from landowners. We're not looking at currently compensating landowners for that, but we are looking to work very closely with landowners as we survey the land. And I guess in the part of the question that I didn't quite get, where there are opportunities for biodiversity offsets, we are happy to work with landowners on exploring those opportunities with them.
Great, thank you, Phil. I'm going to pick on you and go to you again for this one, Phil. So there is a question. This one is from Tabitha again. And it's a question just around if there's proven to be more koala clusters in the new study area, will it be moved back to the previous line to protect them?
I guess where we're moving to now is that we're starting our on-the-ground biodiversity assessments, which will include detailed koala surveys. We survey koalas by a number of means, including spotlighting, drone thermal surveys where we've got access. We will need to do a biodiversity assessment on the new route and consider the significance of those assessments. I guess what our objective is to avoid impacts where we can. Where we can't avoid them, we seek to minimise them, and then finally through offsetting of the residual biodiversity impacts.
Thank you, Phil. All right, we've had another question come through from Tabitha. Why were major constraints with the previous study corridor not identified during 2022-23 desktop assessment, 23-24 strategic design, or the 24 scoping report, i.e. the steep terrain, spoil volumes, and helicopter dependence? Joel, is that one that I can pass to you?
I could probably do a high line, and then if Doug or Julian want to sort of jump in and update on there. So typically under the design process, you start off with limited information. You do optioneering assessments. It's based on high-level metrics. There was a view, it was under when we were looking at options assessments at that time, there was consideration there that some of these areas did have difficult terrain and that it would need to be assessed. It's not until we went down and looked at detailed tower pad modelling, access track modelling, civil earthworks modelling that we were finding this quantum of issue. So we really had to do the detailed assessment, looking at some of these components in terms of doing the models under PLS CAD for where you're going to put the towers and the drapes, along with the civil earthworks to sort of quantify the extent of these items through there. Don't know if Julian or Doug, if you wanted to add on to that in any regard.
I think that's a good summary. Joel?
Great, thank you so much, Joel. All right, we've got a question come through from Tim White. What is the estimated budget for the New England RES high voltage transmission line project? Doug, I know you probably touched on this a bit earlier, so I might throw to you.
Thanks, Mel. Thanks, Tim. Hope you're well, Tim. I think the cost side of things is something that we're working through now, I suppose. So we're in the middle of a network operator procurement process now, or in the middle of. We're sort of about to launch into the request for proposal stage, and that's the stage when we will actually get cost estimates from the market. We've, as you're probably aware, we shortlisted 3 parties, so we're going through that process now. The end of that, we'll get cost estimates. That'll include raising finance, because this is a project that we look to raise, asking the private sector to raise finance as well. So they will tender that back to us, and then we will evaluate that. I guess from our perspective, the overlays that we get in that sense from a regulatory perspective, sort of the checks and balances, if you will. I guess there's twofold. Well, there's a couple, but there's several regulatory checks, but the ones that are probably most relevant for this question. Firstly, we go through a network authorisation process, and that's something that the consumer trustee, AMO Services Limited, undertakes, which is looking at the appropriateness of the network that we're delivering and whether it delivers the consumer benefits, etc. So that's independent of Energy Co. The second one, also independent of Energy Co, is the AER, the Australian Energy Regulator, who will do our revenue determination, and that's probably the most relevant part for cost estimates. They will assess whether that is the cost estimate is in line with what's acceptable to consumers, coming at it from a few different lenses, but ultimately whether that is a recoverable cost. So there's a few checks and balances that will go on, and the cost estimate is typically made, and the process of review of those and the outcomes of that assessment are typically made once the AER has actually made its revenue determination.
Thank you, Doug. All right, the next question is from Bruce Foy. Julian, I'll pass this one to you. The question is, landowners that do not host a transmission line but equally experience an erosion of property value due to close proximity, how will they be compensated?
Look, a really challenging and common question we get. At present, our best outcome for that is to try and work with landowners and communities to minimise that range of impacts, and to try and understand how we can reduce that potential impact overall.
Thank you, Julian. We've got another question that's come through from Tabitha. Why was the MCA changed from the 5 planning pillars to 3 foundational principles? Joel, is that one that I can throw to you?
I'd probably ask maybe Phil if you could probably talk to that better than I could.
Yeah, I can talk to that one. So EnergyCo has its 5 planning pillars that Doug mentioned earlier. Subsequent to the development of our 5 planning pillars, the DeFi, the Department of Planning, Housing and Infrastructure, released the transmission guidelines, and the transmission guidelines talk to 3 foundational principles. So we're considering both the foundational principles and our planning pillars in the planning of the project.
Thank you, Phil. We've got a follow-up question, so we will stick with you. Was the MCA restructured in a way that favoured the new corridor?
Short answer is no. The MCA assessed the new corridor against the previous study corridor using the same metrics for each.
Thank you, Phil. I'm going to go back to Tabitha's original questions just to make sure we've covered those while we're waiting for any others to come through. It's about the fixed wing aircraft, so Phil, probably another one for you. How many times has fixed wing aircraft been used in the last 10 years? I think it's over Chaffey Dam for firefighting.
Yeah, I can't answer how many times it's been used in the last 10 years, but what I can say is that both RFS and the 2 operators, Pays, who operate out of Scone, and Kennedy, who operate out of Gunnedah, all those stakeholders informed us that both Chaffey Dam and Lake Glenbourne are important reservoirs for firefighting, in particular for the fixed wing Fireboss aircraft.
Thank you, Phil. A question's come through from Jackie Osmond. It's another one on cost, Doug, so I will hand this one to you. How can the parties do a cost estimate if the proposed route has not been finalised?
Yes, well, yep, sorry, just make my audio work. Yeah, look, that is a challenge that we are managing through that network operator procurement process. I won't get lost in the weeds of that process, but I guess the initial focus that we are doing with the network operator is looking at constructability and buildability and some other matters, and that's to give us time to work through some specific issues, I suppose, with the network operator, the tenderers. As you've heard on this call, we look to narrow the corridor down from 3 kilometres to 1 kilometre in parallel. And this is one of the challenges that we obviously have is doing work in parallel to meet the timelines that we need to meet. But by narrowing that corridor down early in the new year, early in 2026, then that will be ready, I guess, to then actually refine the corridor and provide that to tenderers when they actually get to the pricing stage of their tenders, which is a little bit later. It's not the first thing they do. They spend a fair bit of time up front. I don't want to get you lost too bored in the detail, but they spend a fair bit of time doing power system modelling and thinking about how they're going to lay out the network from an infrastructure and an equipment perspective, and how they're going to tie into the transgrid network. And then we'll come back and overlay to that how they're going to build the project and then price it and risk it. Hopefully that wasn't too waffly an answer, but there's steps that we are putting in play into the procurement process to allow us time to refine the corridor and ultimately get the network operator tenderers to price the refined alignment.
Thanks, Doug. While we are with you, we've got another one around cost. So this question has come through from Mark. As EnergyCo isn't actually building the lines, can you confirm that no direct taxpayer money will be available to finance the build and all cost overruns will be the builder's cost?
Yeah, it's a good question. So I think just stepping back, I guess the model that we have through the EII Act that we're operating in is that energy consumers will pay for the new infrastructure. That's paid over a period of time through their energy bills, I guess, ultimately. So that's sort of the fundamental model. So that is what we're looking to recover. We call it sort of cost recoverability. And that's where we get that's why we've got the regulatory overlays that I talked about. The consumer trustee, who is there to ensure that the consumer's interests are looked after, and that what is actually bid back is both a network that deals with or delivers, sorry, the infrastructure that is required as determined by sort of AMO and ASL. And it's also value for money for consumers. And those are the checks and balances that get applied through the regulatory lens. So coming back, sorry, a pop-up just got in my way of the question. Coming back to the question, we are looking to maximise private finance. We are looking to wholly finance this through the private sector. That's a work in progress. That's a tender process that we go through to make sure that we can actually raise that money. Certainly the current intent is that that is the case, and that the taxpayers are not on the hook for money, that we set it up such that ultimately the consumers are the ones that are funding the project.
Thank you, Doug. We are coming up close to 6:30, so we've probably got time for a couple more questions. This next one is from Bruce Foy, and Phil, this one will be for you. Has the disruption to rural airfields used for crop dusting been factored in?
Oops, apologies, just getting my mic working. Yes, so we are looking at airstrips along the route. We've engaged consultants to assess impacts on local airstrips. But I guess what's really important is that we want to have those local conversations with landowners to understand how they use their land, including local airstrips, so that our consultant can take that into consideration as they prepare the aviation assessment for the EIS.
Thank you, Phil. All right, we've got a question from Bill. I haven't heard reference made regarding Dungowan pumped hydro project and eventual connection to the grid. If that were under consideration, is there room to move the proposed line further to the west and pick up on that connection requirement? Julian, is that something I can throw to you? Or Doug, I can see you conferring there.
We are. Nice handover. So I think the way that we've looked at the corridor, the transmission lines, is basically, as you probably heard, we're looking at how we can actually get from Bayswater up on to the res, or into the res and connect to the hubs. So it's been very much focused on how we go about building that from a constructability perspective, but obviously with the various overlays that we've talked about through the planning pillars. So environmental and community and landowner impacts are obviously very relevant to that. That's been the primary driver for the transmission line route, and that's sort of where we're looking to get feedback is from landowners on how we refine in that corridor. To answer the question, I suppose, it's a direct question. I guess the assessment that we've done is looking at what we think is the most efficient and effective way to connect the res, rather than looking to pick up individual generators. I guess an individual generator, it's up to them how they connect to the grid. We're obviously providing multiple opportunities within the res at the hubs to connect. I don't think Dungowan's going to run a line necessarily all the way back, well, they may, but that's something that we work with the generators for, to, I guess, have the infrastructure in the locations that are probably the most effective or efficient as we can. Just recognising that there's a certain amount of uncertainty in which generators are actually going to ultimately be successful. And when I say successful, I guess I mean that they're going to get planning approval, they're going to get access rights to connect, and they're going to get to an investment decision to actually let them proceed. So there's quite a lot of unknowns in that space that would make it probably challenging, I guess, to move the alignment just to pick up a single project.
Beautiful. Thank you, Doug. You have taken us right up to 6:30, so good timing. So Thank you to our panel for taking the time to answer everybody's questions tonight. There were some really good questions in there, so thank you. Thank you to everyone for your questions who participated tonight and for choosing to spend your evening with us. We really appreciate it. Your questions will actually really help us understand the areas that we need to focus on as we work to refine the 3-kilometre study area down to the 1-kilometre corridor. It really helps, genuinely helps shape the work ahead, so thank you again. If we didn't get to your question tonight, I think we got through most of them actually, but if there are any outstanding or if something comes to mind later, please reach out to our team anytime by phone or email. We'll pin those details in the Q&A section now. And just a reminder again that this session has been recorded tonight and will be available on the Energy Co website shortly. We will share that link with you once that is live as well. So with that said, on behalf of Doug, Julian, Phil, Joel and the broader Energy Co team, thank you again for joining us. Have a safe evening, everyone. We look forward to connecting with you again soon. Good night, everyone.